Good morning, everyone, and thank you for joining us today. My name is Alma Ahmovic. I'm part of the student network team, and I will be hosting the webinar today. So before we start the presentation, I just wanted to let you know that the webinar is going to last approximately 1 hour, 50-minute presentation, and at the end, we will have about 5 to 10 minutes for questions and answers. So if you have any questions as we go along, please feel free to type them in the question box, and I will run through them at the end. The webinar is going to be recorded, and you will be able to find it on the BANT website under the student section, together with the recordings of the past webinars. Our presenter today is Miguel Toribio-Mateas. Miguel is a nutrition practitioner and a clinical neuroscientist. He got Santander Bank scholarship for doctoral research in 2016, and he's currently a doctorate candidate at the Middlesex University investigating the impact of nutrition in brain health. He's also chair of the BANT, and he has been involved with the organization since 2008. So during today's webinar, Miguel will cover why detox is for life and not just after Christmas, exploring how detoxification is a process that takes place in every cell in the body, 24/7, every day of your life, and not just in the liver and kidneys. Miguel is also going to explore what you can do to support healthy detoxification by choosing the right foods and supplements, as well as the right lifestyle. So Miguel, please welcome.
Thank you so much, Alma, for the introduction, and welcome everybody to this session today. So I've got quite a few slides, so I'm going to be, let me just get the slides working. So I'm going to be introducing, first of all, the aims of, just to become acquainted with mostly the physiology and biochemistry of biotransformation, which is another word for detox or detoxification, explore some of the imbalances that you can encounter in detoxification issues, know what kind of environmental factors can be implicated in biotransformation or detoxification, and then explore what kind of things you can do every day, because as Alma said, detox is not just something that you do for a week or 2 weeks or a month. In January, it's that can be part of it, but it should be part of everybody's routine every month of the year. So Alma introduced me already. I'm a nutrition practitioner with a clinical practice. I graduated in 2009, and I've been practicing since then. And I studied clinical neuroscience at Roehampton University, completed my master's in 2016, and went on to a doctoral degree at Middlesex University, where I'm looking at the effects of nutrition on brain health and how nutrition practitioners actually deal with that kind of situation in clinical practice. So I'll be sharing more details of my research soon, as it's just gone through the board. So I'll be actually starting the research in the next month or so. So I'll be sharing more details of what I'm going to be doing with you. I'm sure if you follow me, you'll find out about it. And I've been involved with BANT since 2008 and chaired since 2012. I was actually a student member of BANT in 2008, and I found the experience amazing. If you have any inclination to help your profession develop into what will be your profession in the future, would really encourage you to be involved as a student volunteer, because it gives you an insight that you cannot really get in any other way. I'm sure Alma will share that feeling with you as well. So if you're tweeting or Instagramming or anything on social media, I'm just Miguel Mateas, and I'm quite active on both Twitter and Instagram, not so much on Facebook, but you can also find me as Miguel Mateas in all networks, on LinkedIn as well, just the same handle. So if you're interested in finding out what I tweet and Instagram about, that's my my social media in there. And first thing is that I wanted to cover today is that detox is not a myth, and you will hear this from a number of different people, that detox is rubbish, that it doesn't mean anything, it's a marketing term. And I tend to agree when this is something like you see in the shops, detox tea that you drink for 2 weeks, and it helps you eliminate toxins. Or like, for example, the other day I was in the supermarket and I bought some bath salts, and they had eucalyptus essential oils and something else, and in the package it says it aids detoxification. Well, I'm not really sure how it does that, so I can understand that some people actually want to know exactly how something is going to happen, and if there isn't a precise science that is describing it, and actually science that applies to a human being as opposed to science that's been done in a petri dish in a lab, then they are going to be funny about using these terms. So putting in that detox in that context, actually one can understand how some people may think it's a myth. But after the presentation that I'm going to share with you today, I'm sure that you'll agree with me that this is definitely not a myth, and it's something that is happening in every single cell of your body from the moment that you're conceived until the moment that you die. So it's the fact that we're exposed to toxins on a regular basis from the environment, from the water, from the air, that we live in is a reality, and the body needs to deal with them, and you can actually help the body deal with them. It's not something that the body will just do passively. It will respond to a number of inputs in the way that it deals with those toxins. So we'll explore that. So detox is actually called biotransformation in many scientific pieces of literature that you'll find it, and it has been documented for many years as detoxification, biotransformation, detoxification. You'll find it with different names in different sources, and the gist of it basically is that you have an exposure to a toxin. Toxins may have different classes, so they may be heavy metals, they may be ammonia, which tends to be produced when you eat too much protein, for example. Organotoxins, which could be pesticides, for example. Again, if you're eating non-organic food, or equally, even in organic food, there may be some remnants of organotoxins. Things like a weed killer can be an organotoxin. You have pharmaceutical toxins. Anything as a paracetamol, for example, is great. It will take your headache away, but it's definitely something that needs to do carry out a specific action in the body, and it needs to be eliminated. And that's the process of detoxification, is the process of biotransformation. You transform that drug, that substance, into something less toxic, and then get rid of it either by means of the urine or the feces. So there are various phases of detoxification. We're going to be looking at them in quite a lot of detail, but that's the gist of it. And the reality is that some of the substances that are not biotransformed, so they are not detoxified out of the body, can accumulate, and that accumulation can cause damage to specific organs or systemically. And this is, again, very difficult to reject as a theory anymore, and as a reality, when everybody must be aware of this plasticizers, how everybody's talking about plastic being found even 11 kilometers deep into the sea. If the environment and the animal bodies were able to just get rid of these toxins and as if by magic and do something with them that takes them away completely and make them disappear, we wouldn't have the accumulation of plastics that are now in crustaceans, in fish, mercury in fish that is coming into a food chain. So we have all of these problems that are actually coming into human health, and they are becoming very much of a reality. So it's very difficult to say that that detox is actually a myth anymore. So we are really a combination of what we eat, drink, breathe, touch. When you're touching anything that's plasticized, you're actually exposing yourself to those plasticizers like BPA, for example. And you are you also are what you cannot eliminate, because it becomes part of your body. It becomes accumulated in tissues. So you have different sources of exposure, and each of them will have different pathways that will affect your body's health and your brain's health. If you see the brain slightly different entity to the rest of the body, the source can be water, air, food, soil, dust, sediment. There's mycotoxins in dust, for example, which is you'll get loads of ideas as to where you go to find what area actually resonates with you. Dust is something that is spoken about a lot lately by researchers and practitioners who are talking about mites in dust, so tiny parasitic organisms in dust and the effect that those have in the body, as well as mycotoxins or mold, for example, is being talked about a lot as well, more in American circles than in the UK yet, but it is definitely a source of exposure. Then, according to how your body is able to get rid of that toxin, that could lead to bioaccumulation. So it's all about a fine balance between exposure and your body's ability to eliminate and metabolize these toxins. So pollution, for example, is a huge source of toxins that we're exposed to on a regular basis. We have air pollution, water pollution. If you're not using a filter, at least at home, to just even a jug with a plain filter that you can buy in the supermarket, you're probably drinking a certain amount of heavy metals, probably copper if you live in a house where the piping is copper piping as opposed to plastic piping. If it's plastic piping and it's not BPA free plastic, which probably would be very sophisticated, you are exposed to BPA. If not, you're exposed to lead if it's a very old house. So my house is about 400 years old, so I probably am exposed to all sorts of crap in different bits of piping that have been replaced over the years. So having a filter is very important, so minimizing the exposure to those toxins. And again, minimizing exposure is as important or even more important than actually doing anything with those toxins. It's probably the most important thing. So those are going to, pesticides and so on, are going to have a number of different effects on different body systems, and because anything from skin irritation that you can actually see, to increase your cancer risk, to increase respiratory illness risk, cardiovascular illness, and so on. So another chart in here, we see how the exposure can actually come from ingestion. So you can ingest a toxin in a moldy piece of food, for example. It could be endogenous toxins, so toxins that are being secreted by your microbiota, your gut flora, your gut microbes, that when they are not in a good balance, some of them that normally would be non-pathogenic, they may become slightly more pathogenic than expected, and they start releasing certain substances that actually increase the amount of free radicals that are available in the gut, as well as how the gut immune system itself actually reacts to these toxins, which can increase inflammation in the gut. So that's a main source of toxins, actually comes from your own microbiota, your microbes in the gut. You also have dermal contact, and you will be very aware of this. You know, if you're using bleach, for example, and you're not wearing any gloves, if you're doing any kind of like cleaning in the house, or any household products that may be abrasive, you may actually get very dry skin or irritated skin. Inhalation and ventilation, again, I react really badly to perfumes, for example, and cigarette smoke. So that's the typical kind of thing. So you can have a reaction that you can really feel by means of dermal contact or inhalation, and that is then going to affect different systems that will intervene in the uptake of these toxins. So it could be the gastrointestinal tract, the skin, the eyes, or the mucosal tissue, the lungs. These toxins then will be transported to primarily the liver, but then the liver also talks to the lymphatic system, trying to get rid of some of those toxins. It will try and deposit toxins that cannot be disposed of quick enough in adipose tissue, which is why fat tissue actually is safe for toxins, and the more fat there is around the middle, visceral fat actually is like a magnet for toxins, because the body is lazy and it will do the minimum amount of work to get rid of the minimum amount of toxins that it can do just to get by, and it will tend to accumulate toxins in adipose tissue because that's a lot more energy efficient than actually detoxifying the toxins completely. And some of the toxins are actually very lipophilic as well. They really like fat. So having extra fat in the body actually gives you more chances to trap more toxins in your body. If if this balance of accumulation and disposal is more towards the accumulation, then you'll have toxins accumulating in things that are in tissues that have very low turnaround, like bone, for example, and brain. Brain is a major source of this kind of magnets that will attract toxins, whatever can go through the blood-brain barrier, because the brain is mostly made of fat, so it's about 70% fat, and fat with lots of bonds, because it's very complex fat as well. It's very long chain fat, and so there's a lot of tiny nooks and crannies for toxins to latch onto in brain fat. And then you basically go into the excretion, and as a rule of thumb, and you either excrete via the feces, and that will be anything that's based in fat and will be broken down by the bile, will go out in your poo, and anything that's water soluble will go out in your kidneys and in your urine, basically. So and if anything is actually ethereal, a volatile compound like paint fumes, for example, it will go out via the alveoli in the lungs and will be expired in your air. So that's another source of getting toxins. So BANT did this Detox for Life chart that, if you're new to BANT or relatively new to BANT, you may not have seen already, but it was released at the beginning of last year, and it basically, if you had to keep one slide from this presentation, I would like you to keep this one slide. It's talking about how you never are going to be able to get rid of all the toxins in your body. Anybody who is really focused on detoxification and makes that their kind of like principal focus of their practice, and it's all about detoxifying and, you know, going into detox retreats and this kind of like obsession with being clean of toxins, they are fooling themselves, because you're always exposed to toxins. Your body is always dealing with toxins that come from a number of different sources. They are floating around you, you're eating them, you're drinking them, you're inhaling them. And the main thing is to try and reduce the exposure. So reducing exposure is always going to be the best way to reduce the total toxic burden of your body. And you do that alongside using a number of nutritional modulators, and we're going to see this in a little bit more detail as we go through, but this is the balance all the time, this detoxification system that is ruled by a number of different genes. And I think I can actually highlight, let me see, I think I can do spotlight. So is this doing spotlight? Can you see a spotlight? No. Basically, the cloud that you have on top of the little man there is just a number of different genes that are involved in detoxification. So those are modulated by a number of nutrients that you have on the right. And we're going to see how these are involved in phase 1, phase 2, and so on. Right. So, and let me see. I need to go back to. Okay. So detoxification really is better described as detoxification or biotransformation. I prefer biotransformation. I know it's a bit of a mouthful, and when you're dealing with peers, when you're dealing with your colleagues and talking about this, then it makes sense. For somebody in the general public, they will think, what are you talking about? So this is the fine balance as well that we need to always be aware of as practitioners, what language we use with whom. And basically the whole idea is that we have different phases of detoxification. We have a phase 1 where any toxins that we've been exposed to in the body go through a process that involves making those toxins less harmful. So trying to do that by breaking them down. So the first step, which is phase 1, is a breakdown kind of process. It's mainly done by enzymes that are very active in the liver, but all of these enzymes are actually in every single cell in the body. So you have this cytochrome P450, which is a compendium of different enzymes. You know, enzymes are actually pieces of protein that help digest things. You think of digestive enzymes, which is one of the main supplements that any nutrition practitioner will use in clinical practice. And what a digestive enzyme will do to your food, it will help you digest the food. Well, think about these enzymes as digestive enzymes for toxins. So what these enzymes will do, you will produce them as part of 2 different phases, and the first phase helps you break down the toxin, so it's easier to then process in phase 2. And in phase 2, what you get is basically the addition of certain molecules that we're going to cover in a second to make that toxin less toxic, so it leaves the body without causing so much damage. So that's phase 1 and phase 2, really, in a nutshell. So when you're processing xenobiotics, so xeno basically means strange or foreign. So anything that's foreign to the body, so it could be endogenous, as in produced by your own bacteria, for example. So again, if your bacteria are producing toxins, toxic byproducts of their own metabolism. So think about bacteria, they eat food, they eat fiber, and they poo into your colon because they are alive. They are little organisms that are alive. That poo will carry certain beneficial elements like short chain fatty acids, but it may also carry some pathogenic or some toxic elements like potentially heavy metals or recycled hormones like estrogen, for example. So you either not transform that at all, that's a not biotransformation pathway, which may cause tissue elimination if you're not well prepared to eliminate, or elimination if you're well prepared to eliminate because you have all of the cofactors that are needed. Or you may transform those toxins via phase 1 and phase 2 and into elimination. So in phase 1, really what we're going to find is that the body is faced with hydrophilic toxins and compounds. They are the kind of toxins that can be broken down and passed via the kidneys and into urine. So so you've got hydrophilic, means that it's soluble in water most of the time. And then you also are going to encounter lipophilic toxins and compounds. And these are lipo means fat, philic, friendly. So lipophilic is fat soluble, and you need to detoxify this via the bile. So the bile is a bit like very liquid for fat, and it needs to detoxify any lipophilic substances. We'll explore what these ones are in a short while. So this is a little diagram of what happens to lipophilic substances, and so they either go into glutathione conjugation in phase 2. So they basically broken down in the same way by phase 1. It could either be oxidation, which is adding free radicals to break down a molecule by burning it. So that is the way to think about oxidation. We can all think about oxidative stress a bit like the rusting in the chairs when you leave them out in the garden for the winter. And that kind of orange rust is oxidation. Well, imagine these enzymes are actually breaking down fatty molecules that could come into your body. And typical fatty molecules that you can think of are, for example, hormones. So estrogens could be your own estrogens or xenoestrogens. So plasticizers, for example, are notorious for mimicking what the estrogen molecules will do. So when you're exposed to plastic like BPA, your body actually thinks that this looks a bit like estrogen, so it treats it in the same way. And to get rid of that plasticizer, your phase 1 detoxification system will be trying to burn it, that's oxidation, or it will be trying to break it down by shooting loads of water at high temperature. By it, that's hydrolysis. So it's hydro water lysis breakdown. So it's trying to break it down by hosing it at high temperature. So it increases the temperature of the molecule to trying to break it down with water. with like a hose to try to break it down into little globules that are more manageable. Reduction is to break it down into small molecules as well. It's a combination of different methods. And then you go into phase 2, which is typically going to be a glutathione conjugation. Glutathione, as you can see, is one of the most important ones. That's why it's got its own category at the top. Or it's going to go into sulfation, acetylation, or glucuronidation. Glutathione needs sulfur as well as sulfation. So glutathione is a molecule that's a combination of sulfur molecules and vitamin C. So we'll talk about that in a second, but it's one of the main ways of the body to excrete toxins that are particularly lipophilic toxins, which are the ones that that cause most of the trouble anyway. And then you go into sulfation, acetylation, and glucuronidation. They need sulfide, they need acetyl molecules, they need glycine molecules, some amino acids that are key for detoxification that we're going to be covering shortly. But those three are minor pathways compared to glutathione conjugation, which is why glutathione is often referred to as the main antioxidant enzyme in the body and the main detoxifying enzyme in the body, and it's not wrong. So you have these bioactivation and conjugation phases that a lot of the reactions happen in the liver, but they also happen in the gastrointestinal tract, in the lungs, in the kidneys, the skin, and in every single cell in the body. So if you look at neurons in the brain, they will have glutathione molecules, and there will be toxins that try to get into the nucleus of neurons to modify the DNA. And glutathione is actually very well studied as a molecule that stops the toxins doing that. So so when you go back to the CYP liver enzymes, so CYP P450 phase 1 enzymes, again, I'm not going to go through all of these in a lot of detail, but I just wanted to remember that they are key enzymes that have got very long, complicated names, and we know a little bit about them in terms of pharmacology. So a lot of the studies that actually refer to these enzymes are pharmacology studies, because when you get a pamphlet from the chemist, when you have been prescribed a drug, and typically it's not an aspirin or a paracetamol tablet, so something a bit more substantial like an antibiotic or warfarin or anything like that, it will have a pamphlet that actually tells you how this is going to be processed by your body and how it's going to be metabolized. This is something that I was actually quite surprised, because in Spain the pamphlet is about 3 times as long as it's in the UK. So when I first came to the UK and I saw the little pamphlets you get with drugs, I thought, is this all you get? Because in Spain people are quite obsessed with knowing how things work in the body, so they get a lot more literature in the with the tablets they are taking. But this is the first kind of line of the liver trying to detoxify these enzymes, detoxify these substances. So they will go through different tubes in the phase 1 detoxification system according to what of those tubes is actually best prepared to detoxify them. You will hear about this in terms of nutrition as well. So there's a lot that you will probably be discussing in terms of how somebody is a slow metabolizer of things like caffeine, for example, and you can have different phenotypes in terms of how you react to caffeine. So if you're a slow metabolizer of caffeine, and that is actually depends on one of these enzymes in phase 1 detoxification, you don't want to be drinking cups and cups of coffee every day, because you'll probably feel it anyway. You'll feel jittery, you'll feel anxious, and that's the caffeine actually not going out of your body quick enough. That means that you're actually flooding this cytochrome P450 that actually deals with caffeine and is not able to take that caffeine away. So again, if you think about this cytochrome P450 as tubes that are actually helping you get rid of substances that are, imagine a bit like the plug hole in your shower, trying to get rid of that water when you're having a shower so it doesn't accumulate and actually floods your bathroom. Each of these cytochrome P450 enzymes are actually part of these tubes that channel the toxins into the liver or the kidneys, and if you haven't got enough of those channels, then there's going to be some flooding. That's what happens when you drink too much coffee and you have got a slow metabolizing capacity for caffeine, and you actually feel like you're going to have a heart attack. You feel anxious and jittery. So that depends on how many copies of these genes you have. So because cytochrome P450 enzymes are proteins, they are coded by genes. So again, without getting too much into the genetics of it, it does all depend a little bit on genes, but not solely on genes. It's the environment as well that is very important to for this. So there are plenty of studies. So I've just highlighted a couple of them in terms of how you can look at the evidence base. When somebody tells you, I feel very jittery when I eat coffee, have you got any genetic data to look at this? You may have a look at any genetics that they may have. There are loads of panels out there, again, out of the scope of the presentation today. But one of the things that is normally analyzed in nutrigenetics is this caffeine metabolism, because everybody likes a cup of coffee and they like to know whether they are getting rid of the caffeine quick enough, and if they are not, it can cause problems. So again, more on phase 1 liver enzymes. They detoxify a number of different compounds, and you'll be surprised that they detoxify not only drugs, but they also detoxify things like caffeine, alcohol, hormones. And if you're to look closely, and this is a field that is emerging, they're obviously involved in the metabolism of things like polyphenols as well. So polyphenols like resveratrol and the catechins from green tea and so on, they're actually classed by the new school of thought as xenobiotics. So they are so powerful, they act like drugs. They're very difficult to break down. They tend to be a combination of lipophilic and hydrophilic substances. So they like a bit of water and a little bit of fat, and they can be difficult to break down, which is good because they actually not being able to be broken down quickly enough. They do good things in the body, but they do go through these channels as well. They do go through the cytochrome P450. The example is that CYP1A1 actually is responsible for the breakdown of DIM, which is that very long name, diindolylmethane, which is the substance in broccoli that is actually a protector from cancer. For example, one of the protectors from cancer. So that's interesting. So they do a number of different things. Then there's also some foods and some drugs that some inducers of this cytochrome P450. An inducer basically means that it's going to make the system work more effectively, faster. And when you make these tubes work faster, again, imagine going back to that analogy of the shower tray when you're having a shower. Imagine your shower tray, the black hole is actually a bit blocked, and you have your shower at full blast, and the shower is slowly increasing to the point that you need to close down the shower because the black hole is not swallowing the water fast enough. That is when you're a slow metabolizer of something. So that water could be testosterone, it could be dioxins, it could be pain fumes, anything. If you're exposed to any of those, there's going to be accumulation. That accumulation can lead to tissue accumulation. So if you're a very good metabolizer, you can have the shower going and even more water, buckets of water thrown into your shower tray, and your black hole is swallowing all that water and getting rid of it very, very effectively. Now, some foods and even some toxins can actually have that effect as well, can enhance that ability of that channel to take away that substance. Niacin, for example, is a known phase 1 enhancer or inducer. Riboflavin as well, so B3 and B2. alcohol actually enhances phase one. So initially, when you're drinking alcohol, it's detoxifying to a point because you're enhancing or inducing phase one enzymes, as well as brassica diets. So all of the brassica foods, so broccoli, cauliflower, which is why they are normally used as liver foods or detoxifying foods. But they're mainly working on phase one, which is important to remember as well. So that's the phase one. So you also break down hormones, as we've seen a couple of times already, because in phase one you have a cytochrome P450 enzyme breaking down progesterone into 17-OH progesterone, which is the precursor to androstenedione. It's a very long name. That then actually makes testosterone. And we both need testosterone as males and females because it's needed for memory, for energy. So it's not only a male thing, it's actually a very important step in there. So if you haven't got enough of the phase one enzyme that breaks down progesterone into 17-OH progesterone, you may struggle with energy as well. So again, just exemplifying that detox is not all about being virtuous and clean and not having toxins. It's about basic processes in the body that take place that require these enzymes. So phase one is actually a very fast-acting. I'm just going a little bit quick with this. It's a very fast-acting phase. It actually works by producing more of these enzymes by coding them, because some of the inducers actually work directly in the nucleus of cells. So you're actually working directly into the DNA and enhancing gene expression of these enzymes. So you're making more of these enzymes. You're making more of these enzymes when you expose yourself to the inducers, which helps you then digest these toxins, going back to the example of digestive enzymes. So again, if you're making more of these peptides, of these enzymes, then you actually digest the toxins more effectively. So again, just a summary, some of the inducers: industrial chemicals, pesticides, alcohol. Cigarette smoke is actually an inducer of phase one. So if you're a smoker or if you're a passive smoker, you may be inducing your phase one detoxification phase, as well as fasting. So when you're fasting and actually drinking coffee, for example, which is another inducer of phase one, although it's also an inducer of phase two because it's a nice modulator because it's very rich in antioxidants. We'll take a look at that in a second. When you're fasting and smoking is possibly the worst thing for phase one. It will give you a lot of oomph, a lot of power on phase one, which can then damage the liver, as we will see in a second. So again, effects can be rapid. Blood levels of the drug that you're trying to eliminate can raise in the individual who's trying to get rid of them very quickly, especially if you're not able to push them through into phase two detoxification quick enough. So you're increasing the half-life of drugs very quickly. So you can also inhibit phase one with certain compounds like green tea, ellagic acid that comes from raspberries and berries, resveratrol from purple grapes, and also from supplements, and DHEA potentially, which is technically a controlled substance in the UK, but is a food supplement in the US. So as loads of different inhibitors, I'm going to leave this for you to read. I just want you to get an idea that, again, inhibition and induction of enzymes is never clear cut, because you never only eat one thing. You wouldn't just eat the resveratrol in the grapes. You're also eating some, if you're eating grapes that also have some seeds in the grapes, you're chewing them, you're also getting another compound in there, the proanthocyanidins. If you're having garlic, you have about 100 different types of sulfur in the garlic. You're not just having allicin, which is what normally is referred to as an inducer. You're having watercress, you're not just having sulforaphane. So they all have their own modulating properties within themselves. So I'm just, I want to go through a little bit faster because I wanted to leave some of this more technical detail for you to read later. So the pathological detoxifier situation is when you're upregulating phase 1. Imagine not something that many people will see on a regular basis, but there are still people who are getting up, not eating anything until lunchtime, and they're having cigarettes, for example. They're going to upregulate their phase 1. The downregulated phase 2 is a potential situation. If you're not pushing the toxins from the cigarette, like the nicotine and so on, quick enough into the phase 2, that may be downregulated because it's a diet that is very poor in the nutrients needed for phase 2, which we're going to see in a second, then you may get the intermediate liver damage by the toxins, and that's actually a reality. So that's how liver damage actually happens. So I have another slide somewhere. Okay, so this is has got a nice diagram. So if the toxins go from phase 1 to phase 2 in a nice way, that actually the person who's trying to detoxify any toxin in phase 1 has got all the different substrates for phase 2 to happen in conjugation pathways, loads of sulfur from brassicas, loads of polyphenols from different brightly colored foods, then they're going to go nicely into phase 2. Otherwise, there could be some damage to the actual liver because of high amounts of free radicals that are used in phase 1 to break down the molecules into small molecules. So it's one of the things that we actually looked at, the oxidation, which is one of the main ways to get rid of toxins in phase 1. So in phase 2, and this is the conjugation pathways, normally referred to as conjugation pathways, you get rid of a number of different xenobiotics. A lot of this you will see in paints, in things like face creams, toiletries, toothpaste, shampoo. If you read any of these xenobiotics that you actually have in here, and you just buy a L'Oreal shampoo, you'll probably find a few of them in there already. There's also methylation of things like mercury and lead, the heavy metals. There's arsenic that you can get from just eating seafood, for example. That's actually quite rich in arsenic. If you eat loads of prawns every day, you may have higher levels of arsenic, so you may need more methylation than the average person. You get a number of different drugs that are actually metabolized in phase 2, like the salicylates. So aspirin, for example, needs glycine conjugation, and a number of different compounds. So this is the thing as well that I want you to take a very special look at. Just because vitamin A is a vitamin and is natural, when you having vitamin A, it's to the body is a compound that is like a drug. So it needs to be processed like a drug. It's got a half-life like a drug. It's doing whatever it needs to do, like any drug would do, and then it needs to be excreted. And vitamin A, vitamin K, and vitamin D, as well as vitamin E, the main lipophilic nutrients that you need for a number of different things in the body, they are excreted by glucuronidation. So that's the pathway that they need to use to be detoxified. Neurotransmitters need to be detoxified, like dopamine, for example, or cortisol will need to be detoxified. So that's a catecholamine. So catecholamines are like cortisol, adrenaline, and so on. They are detoxified by means of sulfation. So sulfation needs sulfate, it needs sulfur. And that's why brassicas, again, help you detoxify hormones. So when you give somebody this snippet of this soundbite, oh, I'm going to give you a diet that is detoxifying, that is rich in liver foods like broccoli and cauliflower and so on, you don't need to get into all of the technicalities and the science, but what you're basically doing is you're enhancing phase 2 detoxification via sulfation pathway. So basically what you're doing in phase 2 is you're adding another layer. You're getting little globules of toxin that has been broken down in phase 1 and making it less toxic so it can actually leave the body without being recirculated. So you're adding a layer of another compound, and the compound could be sulfur. It could be, that's why you have sulfur in there, glutathione, acetylation, methylation, you're actually adding another molecule. Could be an acetyl molecule, a methyl molecule, a taurine molecule, a glycine molecule, to make the toxin less toxic on its way out. That's what I need you to remember from phase 2. So you have a number of different conjugating agents, and you're adding any of these agents via any of those pathways. So the toxin that you have processed already in phase 1 actually is less toxic as it leaves the body. So these enzymes are primarily present in the cytosol. So this means in the watery bit that surrounds the nucleus. And the reason why they are there is so the toxin actually doesn't reach the nucleus, because the nucleus is a bit like the operating system of the cell. So if the toxin is able to get into the nucleus, because that's where the DNA is, it can actually either break or modify the DNA. If it breaks the DNA, the cell can die, which is why, you know, in theory, toxins can actually make you age and give you illnesses, because it basically kills some cells. But also it can help cells mutate into other types of cells. So a healthy cell could mutate into a cancerogenic cell just by changes in the DNA. So again, this is a very important slide, and I'm aware of the time. I'm going to go quite quickly on the rest of the slides, because to be quite honest, a lot of what I'm going to cover from now on is being covered already. And if you take the BANT slide and you take this slide, you know everything there is to know about detoxification. So you've got your toxins that are coming into your body. They are going to be either non-polar toxins or polar toxins, so either lipid soluble or water soluble. They're going to be broken down by a number of different reactions in phase 1. The main one is oxidation. So always remember phase 1 as oxidation, as increasing heat and increasing the free radical formation in the area surrounding the toxin. So it's actually fried. It's almost like fried with heat and broken down into tiny little molecules. This is going to release a lot of free radicals, a lot of superoxide radicals. So that's why a lot of nutrients are needed that are going to soften the damage that the surrounding tissue can suffer as a result of these reactions. If these reactions are enhanced by cigarette smoke, by grilled meat, by fasting, for example, which all enhance this phase, and is not corresponded with proper ability to get rid of those toxins in phase 2, there's going to be intermediary metabolites, there's going to be reactive oxygen species that are actually released as a result. More oxidation is going to be resulting, that's going to damage the tissue. And in order to protect the tissue from that damage, then you have a number of different nutrients that help you with that. And there are selenium, copper, zinc, manganese, coenzyme Q10, bioflavonoids, pycnogenol, all of the garlic compounds and onions and cruciferous vegetables. They all help in this intermediate phase between phase 1 and phase 2. And phase 2 then gets rid of what is left. And it does that by actually using glycine, taurine, glutamine, N-acetylcysteine or NAC, which is used as one of the main detoxifiers, cysteine and methionine. A lot of these you see are actually sulfate amino acids. So sulfur keeps coming back as a very important, and that's why we always talk about cabbage, broccoli, cauliflower, onions, spring onions, all of the sources of sulfur in the diet that are actually giving the substrate for these reactions to take place. So I hope that everything is kind of like making sense by looking at this. Then you have your excretory derivatives, which are basically the toxins going out, which are going to be metabolized in the bile if they are fatty toxins, or in the kidneys, and if they are watery toxins, and then excreted in the stool or in the urine. Endotoxins are important as well. So endotoxins can be mostly from bacterial bacterial dysbiosis. So those are to be taken into account. So again, it's for another presentation, but you do have this kind of situation. And of got loads of charts in here that talk about the same thing, so I'm going to go very quickly. Then there is this phase 3, and phase 3 is less talked about. I only have this one slide to let you know of it, but enterocytes, which are the cells that are coating the line of the bowel, are involved very acutely in the detoxification process, and depending on mainly on the state of your microbiome and your gut microbiota, your microbes, toxins can recirculate. So if you hear about phase 3, it's mostly talking about recirculation of toxins. I haven't included it in here because it's a little bit out of the scope of the presentation, but there is this kind of thing about recirculation of estrogen, for example, and one of the molecules involved is beta-glucuronidase, which is released by pathogenic bacteria. So it's the result of dysbiosis. So, and that's why polyphenols actually not only help with being antioxidants and anti-inflammatory agents, they also feed the microbiome. So you keep your microbiome, your healthy microbes in the gut healthier, and there's less inflammation, more short-chain fatty acids that are anti-inflammatory, but also there's better gut barrier, tight junctions, gut barrier integrity. So the enterocytes are actually working better in detoxification. So that's why all of these polyphenols that we refer to all the time, bright colors, eat the rainbow, what you're doing is you're keeping those cells actually helping you with detoxification in a very nice way. Just you're giving them the chance to be integral and healthy, so they can intervene in detoxification properly. So the liver is actually one of the main organs of detoxification. It's a cyclic organ. It means that actually has been reported extensively as being an organ that's affected by circadian rhythms. So it works mostly when you're asleep. So if anybody's got issues with sleep, then probably the liver is going to be suffering as a result, because it should be working during the night. So if they're awake until 2 o'clock in the morning, the liver is probably going to be suffering as a result. So the liver actually works in synchrony with the biological clock, like the rest of the body, really, but the liver so much more than any other organ, probably at the par with the brain. And if you have things like hypoglycemia during the night, which may be the result of eating too much sugar during the day, then you may have things like night sweats or unpleasant dreams. One more reason to really focus on blood sugar control as one of the main things that you should always be looking for in clinic. One of the main things that I always look in clinic. So a little bit on the exposure to these xenobiotics that we've looked at. We talked about xeno as being Greek for foreign or strange in the body. So it's basically anything that is strange to life in the body, and it could be pesticides, it could be drugs, it could be plants. So it could be, muscarine, for example, which is what kills you in a poisonous mushroom. It could be venom in any animal venom. Some people react very badly to the toxins in insect bites, for example. So, and obviously there's heavy metals and industrial release, plasticizers, and so on. They need to go through the same channels as we discussed before, phase 1 and phase 2. So whenever you're exposed to any of these toxins, they need to go through the same channels for elimination. And there is this theory that a little bit of the toxin actually helps the body build up the system to get rid of it, and this is called hormesis. So you may see this in literature, and there's a growing body of evidence that things like resveratrol, for example, may be doing that, and that's why it helps the body detoxify, because the body sees resveratrol as a toxin, and in seeing it as a toxin, it actually helps develop the system that get rid of similar toxins. But with hormesis, there is the hormetic curve that basically means that a tiny little bit of that toxin may be beneficial, but then it has a very steep reaction. So it's basically like a tiny little bit of of the toxin is beneficial, but past that threshold, it actually is very deleterious to the body. And that's particularly true of endocrine disrupting chemicals, plasticizers, particularly anything that the systems that we've discussed, phase 1 and phase 2, will have trouble breaking down and cannot break down, will be accumulated in the body. And that is a lot of what we're seeing nowadays with environmental exposure to plasticizers, for example, which are very difficult to break down by the body. So I talked briefly about how toxins actually get to the nucleus. So if this is a cell, and you've got your nucleus there in the middle, and you've got your drugs, chemicals, xenobiotics, and you've got a receptor that allows them to go into the cell. And if you then that toxin is able to get into the nucleus, it's going to be able to modify how phase 1, phase 2, and other enzymes actually break down toxins. So that's why some toxins can actually inhibit the breakdown of other toxins. And the more toxins you're exposed to, the more likely you are to be experiencing deficit in your detoxification ability. So there are a number of different receptors that are actually responsible for the metabolism of proteins, the peptides and enzymes that help you detoxify. Again, I don't want to get too technical, but I did want you to see how what the names look like. And we talked about plastics and so on. I really wanted to get to a couple of slides that are very important. This is one of them. You can see the URL in there. This is a URL from the Agency of for Toxic Substances and Disease Registry of the United States. It actually has a whole register of thousands of substances with what they do to the body. So again, another a very important resource that I would like you to keep in mind, because it basically shows that detoxification really is not a joke, it's not a myth, it is real. And these toxins that we've been talking about, even just briefly, plasticizers and so on, are actually known as human carcinogens, as endocrine disruptors, and you can have a look at this resource in your own time. I think you will find it very useful. So this is definitely not fake news. You have some phytoestrogens that actually look like estrogen, and that can actually be beneficial to a point. So it could be the isoflavones, like soybeans, for example, are a source of isoflavones, or lignans like flaxseed or sesame seeds can be useful in situations where you may want to give somebody a little bit more estrogen-like activity. So perimenopausal women, for example, but they can also have the opposite effect in somebody who has got a lot of estrogen. So something to be mindful about. Just because they are naturally doesn't actually mean that they can always be good. So they may not be indicated all the time. And I just wanted to again go through a few of these quite quickly, because I'm aware of the time. But I just wanted to remember a couple of big names. Bisphenol A. Bisphenol A is a plasticizer, is used throughout. If you're drinking from a plastic bottle, water is likely to carry bisphenol A, and it can actually be associated with a number of different endocrine imbalances, including something very simple that you can see in a GP test. So when somebody's got the gamma GT, which is the gamma glutamyl transpeptidase, is one of the liver enzymes. When somebody's got a liver enzyme that is raised, particularly the gamma GT, it can be alcohol, but it can also be plasticizers. It can be plastic-like substances that accumulate in the body. And there's a theory that actually that has an influence in the development of metabolic syndrome and diabetes type 2. So when you're exposed to persistent environmental pollutants or organic pollutants, POPs, that can actually have an impact on the amount of these on your detoxification system. Basically, you bioaccumulate these plasticizers that are they look a bit like estrogen, There are epigenetic changes to the DNA that releases the helps in the metabolism of detoxifying genes, and this has an impact in your detoxification system, basically. And not only that, you accumulate these plasticizers in a way that it leads to accumulation of fat around the middle, and in doing that, you increase inflammation and you lose sensitivity to insulin. So that's a theory that has been shared for a while now, and is getting quite a lot of support. So it could be a number of different things, but that's one thing to look at. There are also a number of other names that I would like you to look at, particularly if you're buying anything that's over the counter, like a shampoo that's made by L'Oreal or any of these big brands, because it's likely to have a lot of these endocrine disrupting chemicals with different names, like that some of them are quite difficult to pronounce, like phthalates, parabens. Again, I'm going a bit quick through this, but you'll get the presentation. So I just want you to remember the big names and what they do, which is basically they disrupt the endocrine system in the body, and that can disrupt your estrogen metabolism, your testosterone metabolism, but also your blood sugar control. So you could end up with a situation where you are more likely to develop sensitivity to sugar and put on weight as a result. And so plasticizers are really some of the nasty things that are floating around in our environment at the moment that we cannot escape, but they are definitely having an effect in our body. Chlorinated pesticides, something that looks like or smells like bleach. So anything, anything from the bleach that you're exposed to if you go swimming, to the bleach in domestos, if you use these cleaning products, but also pesticides that use similar molecules, are also contaminating our food chain, and that's bioaccumulating. And then we get by default when we eat fish, for example. There's a lot of science saying how bioaccumulation in fish is actually real. Wild fish is best as opposed to fish from a factory, and then there's volatile organic compounds, things like paints. When you're painting the house, you will see when you buy your paint, it's got a mark at the back. It can either be low or high. Anything that's based on plastic is actually high. Anything that's water-based tends to be quite low and safer. If you feel sick after painting and you've been decorating the house, that's typical toxic reaction to the volatile organic compounds. Varnish, nail varnish is another one that's actually fairly toxic by inhalation. So that's the volatile organic compounds. And they're everywhere, as well as heavy metals. So you cannot get rid of heavy metals. They're everywhere. They're in dental amalgams, in cleaning products, in aluminium cans, in oysters, in toiletries, in nasal sprays for congestion, in loads of different places. So, but you can limit your exposure, and you can also do something about it with specific nutrients. So minimizing your exposure by increasing the amount of organic food you eat. This is a really good resource to be more mindful of what vegetables are actually dirty as opposed to cleaner in terms of the content of pesticides that they tend to have. So if you're going to buy non-organic, at least you'll know that celery is something that probably you shouldn't buy that day if it's not available as organic celery, because it's likely to have been sprayed a lot more than maybe watercress, for example, which tends to be cleaner. So even if it's not organic. So that's how I look at the soil association. Remind yourself of how important this is. Just be aware of where the exposure is coming from. Salmon is one of those that if it comes from a factory, it's likely to have antibiotics, it's likely to have colorings, it's likely to have hormones, a number of different things that are actually going to impede you from detoxifying properly. So avoid the exposure as much as possible, and up your brassica intake, just because as you have seen is the main source of the compounds that that allow you to detoxify properly, both phase 1 and phase 2. So up your broccoli, Brussels sprouts, cabbage, kale, bok choy, turnips, mustard, anything that you can get hold of in that family. Only if you are hypothyroid, just use it with caution. Some hypothyroid people can use loads of brassica without any issues at all. Some of them can be a bit more sensitive. So losing fat can actually be very useful as well. So this is just a quick example of somebody with a lot of bisphenol A in urine, doing a test, and having lost 5% fat. Then this is the post result. That was post fat. Hang on. This is the okay, so that's the post fat. So it's gone from being in the red to losing 5% fat, going dramatically down almost to the just suboptimal. So just losing fat around the middle can be very powerful in losing toxins that you have bioaccumulated, and they could be impeding your proper hormone metabolism, your metabolism of insulin and sugar. So, and drink plenty of water. My rule of thumb is from 25 to 35 milliliters of filtered water per kilogram of body weight. So if you're about 70 kilos, that's about 2.5 liters of water. So a little bit more than what somebody would recommend, but not masses, so you're not in the loo completely all day. And to me, things like coffee actually count as water, even though it's slightly diuretic, but mostly if you're drinking Americano and not cappuccinos with loads of cream, is mostly water anyway, and you have loads of nice antioxidants in there. Same with tea. If it's not sugary and milky, then it's normally considered as water. Up your fiber content with loads of the lovely greens that we talked about, but also you can add specific fiber like psyllium or konjac, for example. That can help you bring your fiber intake to about 30 or 35 grams a day. If you're struggling, using cholagogues like olive oil, milk thistle, peppermint and dandelion, choline and inositol, lecithin, in 2 minds, but it can be useful sometimes. It can alter the microbiome sometimes, but used in small amounts when needed and when you're trying to lose weight, that can be very useful. Glutathione, either as a supplement or by providing the building blocks of glutathione like vitamin C, NAC. That's very useful. Again, I'm not that keen on the oral supplementation with glutathione, but it can do something to the gut. Actually, it can help the enterocytes with phase 3, so it can be useful on that. You can also take just NAC, so N-acetylcysteine, which is very safe. So you can take a lot of N-acetylcysteine, up to 1 gram and more, and vitamin C, and then your body will make its own glutathione. Obviously, NAC you can take individually, even if you don't want to be contributing to glutathione, because NAC in itself is also a detoxifier, is a binder to heavy metals, same as alpha lipoic acid as well. It's called the antioxidant, the universal antioxidant. It can recycle vitamin C and E that are also really good for detoxification. Magnesium, the really big detoxifier, because it's slightly diuretic, so it helps with excretion of toxins, but it's also required for the formation of cofactors from vitamins B. So all the B vitamins work better if you actually have better levels of magnesium. Another very good chart, if you want to keep the BANT charts, definitely that liver chart that I showed you, and a couple of the charts with all the pathways, and that's all you need from this presentation. Basically, just eat a rainbow of different colors every day. It will give you all of the different nutrients that you need, because you'll be getting polyphenols, vitamins, minerals, all of the cofactors that are needed for detoxification. And I'm sorry I rushed a little bit through the second part of the presentation, but I had a lot of slides to share with you that Alma will be posting, so you have access to them. So I hope that it all made sense and that you got a lot out of it. If you want to keep in touch, find me on social media, and I'll happily answer any questions you may have. But I'm also open for questions now. So thank you so much. Alma, you want to open the question session?
Miguel, hello. Yes, we don't have much of a lot of time because we've run over a little bit, but there's just one question. So there are a couple of thanks saying the presentation was wonderful. Thank you very much.
Thank you.
And I completely agree. It was very comprehensive. So there aren't a lot of questions. So just one question is, you mentioned at the beginning that there are sometimes it is useful to do this, like few week detox or a month detox. So can you just touch on that a little bit? Is there any use of doing these detoxes?
Yes, definitely. I think what is most it's mostly about the semantics, and I think people get stuck on this, and detractors can actually be quite fierce in their opinions. So when somebody says, "Oh, I'm doing a detox," then it can sound a bit trivial. But you're definitely, if you're doing a detox by increasing the amount of brassicas that you're eating, by drinking more fluid, by taking some supplements that can support that detoxification, like these supplements we talked about, like alpha lipoic acid and N-acetylcysteine and vitamin C, and you're increasing your polyphenol content anyway, because you'll be having loads of different colors in your diet. You're probably cutting down on food toxins like the hormones and the antibiotics from meat, because if you're doing like a lower meat intake as well, that may actually cut that down. And if you're not frying, you're actually exposed to less of the toxins from the cooking processes, like the acrylamides and the toxins from charred meat and so on. So you're reducing exposure dramatically, and you're enhancing your body's ability to get rid of any accumulation of toxins that you may have. So even if it's a week, a month, whatever, it's something that you've done to your body that you wouldn't have done before. So I think it's absolutely valuable. And if that's the way that works for you, then that's great. What I tend to agree so much is somebody does the whole of January with no drinking and eating loads of vegetables, and then they eat crap for the rest of the year and they drink every night. So that doesn't seem to be very balanced, and it gets into your relationship with food and how that is something that you need to look at. But so for me, the focus should be that you can do a little bit of detox every day, but just being mindful of these things that we talked about. Just including some brassicas every day is helping you detoxify. Just including a variety of different colors is helping your liver from not getting damaged by these intermediate free radicals that are produced between phase 1 and phase 2. And there's always going to be a certain amount of that. So you can be mindful with tiny little bits every day, with certain amount of supplements if needed. A good multi that has a little bit of coenzyme Q10 or alpha lipoic acid or NAC can actually be a nice addition as well. So if you're taking a multi supplement, maybe look for one that has got those components, which are overall good promoters of phase 1 and phase 2 and supporters of liver function. And then you're doing a bit of detox every day.
Brilliant. Well, thank you, Miguel. Thank you so much. That is all we have time for today. Thank you so much for taking time to present to the BANT students, and this was a really useful and very, very interesting and very comprehensive presentation. I just want to let everyone know that our next webinar is going to be on the 27th of February with Ben Brown, and he will be talking about gut health and IBS in particular. And one more time to thank Miguel for his time and his knowledge, and hope you all have a lovely day. Miguel, is there anything else you want to add?
No, that's very lovely of you. Thank you so much.
Great.
And
Thank you so much.
thanks for having me. All the best. Bye-bye.
Thank you. Bye-bye.